Okay, good morning. Welcome to
FamilyMath911a.
FamilyMath911. So today we're going to do a fun talk about something in physics called general relativity. And before we even start, well, actually, what we're going to talk about is something I saw on Twitter. It's kind of fun. What it looks like when a cube is passing by. So you're sitting still looking at a cube whizzing by you at a particular speed.
Alright.
But before we even get into what we're going to talk about, why don't you tell me what, if anything, you know about general relativity or physics or anything at all?
I think the theory of general relativity was made by Einstein, Albert Einstein.
Yeah, that's right.
And then I don't really know what it means, but I've heard E equals MC squared a lot.
Oh, you've heard E equals MC squared, okay. Let's talk about E equals MC squared.
So I think E is energy.
That's right. Energy.
Energy, mass.
Mass, yeah.
And then that's times the speed of light.
Yeah, times the speed of light.
Squared.
Squared. So it's kind of surprising that this equation relates some mysterious thing called energy to mass multiplied by however fast the speed of light is.
Yeah.
So that's kind of a surprising connection. That's pretty neat.
Yeah.
Would you just run over and grab one of our Rubik's Cubes so we can talk about with a little visual aid what this cube might look like. So when a cube passes by you, if you're just kind of sitting up where the camera is, what do you think you're going to see?
Well, I think I'm probably maybe seeing some sort of.
Let's say it moves this way.
Oh, it's gonna whiz that way.
Yeah,
so
it whizzes by that way. What do you expect to see?
There's gonna be like kind of like a rectangular line going across because you've got these two parallel faces or side edges that you can see no matter what direction. I suppose if you tilted it this way, the line would be like, if you tilted it like this, I think you would see the same rectangular thing because the bottom point here is that's the end of the boundary, and then the top corner back here is going to be the top point of the boundary. So I think it's just going to be like a rectangular prism, or yeah.
Yeah, that's interesting. That's actually a neat description. So you're saying what you think you'll see is just basically
that going by.
Two lines that look like that. Essentially making a very, very long rectangle. Do you think you'd be able to know it was a cube?
No, I mean, if what I said worked, then if you did it with like a tetrahedron, the top corner would be the top point, and then like the bottom face or the bottom corner would be the bottom of the boundary.
Okay, so you're just going to see something kind of whizzing by here, and that's a neat description. So let me tell you about some of the kind of neat things that are implied by general relativity, and then we'll look at two simulations that show what this might look like at very, very high speeds.
Okay.